In this video, I'm going to be going through the Year 11 HSC or Preliminary Engineering Studies. I'm on Chapter 1 and we're looking at materials, specifically M7 ceramics. Ceramics are an inorganic non-metal primarily held in ionic bonds. They are non-metals. So we may have looked at previously the picture of the salt. And we said, what is wrong with the image of the salt? Can't be organic because it's an ionic bond, right? So salt, organic means a carbon-based covalent molecule, whereas sea salt is an ionic bond. Now, obviously, that means that there's different definitions. Paleo Pete has a different definition of organic than me, but we're running with it. Okay, so what we've got left. Ceramics. They are resistant to chemicals. They are usually non-corrosive and typically brittle. They are refractory materials, meaning that they are stable even at high temperatures. I knew what I typed last night. I was going to write here, in this space here, I'm going to say they are strong in compression and typically weak in tension. Okay, so if you can add that note in there, because that's one of the dots that I've since added. So I've made that homework, but it's not a dot there. So just write that note somewhere so you have it. Ceramics include stone, clay products, cement products, and glass. Ceramics are used in abrasives and electrical applications. So I've got here a little bit on stone. There's 3 different classifications of stone. You don't need to know that as far as I'm concerned. There is a very, very low chance it could be in the HSC, but I won't test you on it. I definitely learned it at uni while I was doing geotechnical engineering or soils and things. It's worth mentioning that stone has been used as an engineering product, right? The example of the pyramids. The pyramids, it's important. I always like to say that they're so old that the pyramids are closer to... Cleopatra lived closer to us than she did to the creation of the pyramids. That's how old the pyramids are. Anyway, different people tried to destroy the pyramids, and they found that it's actually as difficult to destroy a pyramid as it is to make a pyramid. So, that's why they were unable to destroy the pyramids, because they thought they were blasphemous. Okay, so we're going to move on to cement and concrete. Cement is used as an adhesive or glue in brickwork and to make concrete. Concrete is a composite of cement and aggregates, sand and rocks. Now, this is literally the most important thing that you need to know in this subject. If you don't know this and someone asks you and if you say the wrong thing, you will embarrass me if someone says, "Oh, I did 2 years of engineering studies and yet I still don't know this," right? This is the most important thing you need to know in this subject as far as I'm concerned. If you only learn one thing, this is the thing you should learn. So concrete is made of cement and aggregates. Okay, reinforced aggregates means sand and rocks, yes. Okay, reinforced concrete, which includes steel bars as reinforcement, is a major part of the construction industry in Australia, and precast and tilt-up sections are widely used. So we add the steel because the steel provides tensile strength. Concrete has no tensile strength. The steel provides the tensile strength. If you want to write that in there as a little note in your margin, steel provides tensile strength. Precast, so a lot of the time, the best example I have for precast is if you drive south to Wollongong, you see these great big noise walls along the side of the highway. They've got dolphins and stuff. They're made out of precast panels. Right, they didn't pour the concrete on site and say, "Oh, yeah, this is going to be a great looking dolphin." They cast that in a factory and then they drove it out and put it up on there. There's now some precast walls if you're going north over the Captain Cook Bridge. You can also see precast panels there. Tilt up is used for factories and things where you don't usually want a very high finish. So what you do is you cast your flat slab, and then what you do is you cast the concrete wall laying down, and then you pick it up and you lift it in place. I did say to the other class that at one point my wife was watching a show called Call the Midwives. It was set like just after World War II maybe. And she goes on this date, and the date won't stop talking about precast and tilt-up concrete. And this was like the quintessential bad date. So I guess I'm going to say that, I mean, I'm not an expert on this sort of thing, but maybe on your first date, you don't want to tell people how excited you are about the wonders of, technological concrete advancement. So anyway, moving on. Okay, concrete represents a major sustainability risk. So why does it represent a major sustainability? There's two reasons. One, it's we're running out of sand. We're running out of good quality sand that we can use for concrete. So we need to use alluvial or sand that comes from rivers, alluvial sand or sand that comes from rivers. We can't really use desert sand. This is why Australia exports sand to Saudi Arabia. They have lots of sand, they just don't have good sand that can be used in concrete. And the thing is, the world collectively is running out of sand that can be used in concrete. Yes? So desert sand is too spherical, alluvial sand is more elongated. And that's important if we want to have it stick good. Yeah? So, if you're interested in this, the best podcast I've ever listened to in my life is the 99% Invisible or 99PI Sand podcast. If you type in 99PI space sand, you'll listen to the best podcast I've ever listened to. I was in a cafe at one point, and someone came and said to me, "What do you mean that we're building as many skyscrapers as New York City every 13 weeks?" And I said, "Well, China is building a lot of skyscrapers." He's like, "And we are really running out of sand." This was a person sitting in another table to me who was asking about the Sand podcast. I strongly recommend the Sand podcast, 99% Invisible. Okay, it's based on a book. I've never read the book. I'm sure the book is great. So the other problem with the sustainability of concrete is that concrete produces a lot of carbon dioxide. It is a leading cause of climate change. Right here we can see it's 8%. In many estimates, it's higher than 8%. There are some people who are working on concrete that actually captures carbon dioxide, so it's actually be carbon negative. And there are people who are looking at alternatives to using cement, so using rice husk, which actually gives good crack resistance and improved, some properties improved. The thing is, a lot of the time when you see these articles saying, "Oh, this is a scientist working on this ingenious innovation," yeah, it's ingenious and it's a great innovation. But unfortunately, it's usually twice the cost, right? So we often see things like graphene has been the engineering product of the future for more than 20 years, right? It's always just around the corner that it's going to do something amazing. And I'm not saying that it won't do something amazing. The point is it just takes a long time for things to become cost effective. Okay. In this podcast, they also start talking about what are the building alternatives that we have beyond concrete. And so people are looking at things like bulk timber. Right, so that's an alternative that we could be using, but it's going to be a big transition away from concrete. So, moving on to another ceramic, the second most important ceramic in my opinion in engineering is glass. Glass is amorphous. That's what the A is for, is amorphous. That means it is non-crystalline. It is transparent, and it has a medium hardness, which is 5.5 on the Mohs hardness scale. Soda lime glass, the most common glass, is used for the things on the side of the walls. Windows and glass. You drink out of them? Bottles. Okay. Gorilla Glass, right, which has I'm not going to say alkali aluminosilicate glass, is more scratch and impact resistant. The person who wrote hard, that's totally reasonable. Now, because I went through this yesterday and I said hard, I'm like, you don't normally say more hard, you just normally say harder when we do a comparative of hardness. But I've had here more impact and scratch resistant. But yes, we know that impact resistant is another word for tough, and scratch resistant is another way of saying hard. Borosilicate glass can withstand sudden temperature changes. Okay, so I'll talk about that briefly. I have a window that talks about glass, Gorilla Glass as fast as possible. what he's talking about is it's hard and it's impact resistant. And you can see people looking at the benefits of Gorilla Glass. I'm not going to go into the details of this. The whole point is that you can look at this in your own time. You don't need to hear him recommend it audible. The point is that glass that is being used in mobile phones is getting better and better. I would have told this story at least once already. Already I would have told this story about my daughter, that when she was maybe a bit more than a year ago, we bought her a mobile phone. Literally within one day, she'd had the phone for less than 24 hours. She dropped it on concrete and it cracked the screen. And she just had to live with it. Her brand new shiny phone. My wife said it was my fault that I didn't buy her the plastic cover. Anyway, we've moved on from this experience. So, the point is that we're interested in impact resistance and scratch resistance, right? So hardness and toughness. So Gorilla Glass, that's Gorilla Glass. As for Pyrex or borosilicate glass, there's a brand called Pyrex. And what we can see is that if we take Pyrex, if we take it out of the fridge and we put it in the oven, it shatters, but it didn't used to. If you had the European Pyrex, if you take it out of the fridge and put it in the oven, it doesn't shatter. And that's because Pyrex sold their brand in America and now is not very good. So it's important that you identify, if you're buying Pyrex, that you make sure, does this have borosilicate glass in it or not. You can tell by the logo if it's a European logo or or not. Just check that. Recording, yep, okay. So we're now on to the more commonly used structural engineering glasses. We're mostly interested in tempered glass or laminated glass. Tempered glass is also called toughened glass. It is produced with an exterior in compression and the interior in tension. So the idea is that we know that ceramics typically fail in tension. They're strong in compression and weak in tension. So what we do is we create an exterior in compression, so that way, in order for it to fail, we has to overcome that initial compression. Don't worry about this too much. We cover this later in the Year 12 book. But for the moment, what we want to know is, what is the end product? What we want to know is, when it shatters into small, safe, granular chunks instead of splintering into jagged shards. Yeah? So what does that look like? Well, we've got this guy here, and he's going to smash some windows. Let's have a look at that one. So, okay, we're ready to go. He just has, here's some standard glass. Let's look at him smash the standard glass. Ready? It's a great job, right? Smash! Okay, this is the last time. Smash. Yeah? Look at those pieces of glass. They look very dangerous. Yeah? I love how in Australia we have the verb to glass someone. Anyway, tempered glass, you see, it still shatters, but it shatters into nice, safe, granular chunks. Laminated glass, though, on the other hand, laminated glass doesn't shatter. Now, this is really good if you're going to hit like a kangaroo, right? Because kangaroos, when they hit your windshield, they kick. Or, if you live in Canada, I have heard that 80% of roadside fatalities in Canada involve a moose. And it's really, like, I think that people don't appreciate just how tall mooses are. I love that I'm getting that reaction, because really, they are just... I remember, like, so I was a grown man before I found out that bears kill people, right? And my friend from Canada, she's like, of course bears kill people. They were like, they're a legitimate threat. But I had no appreciation of how huge mooses are. I think the plural of moose may in fact just be moose, but anyway. So the point is, well, if you hit a moose, you're probably in trouble. But if you're hitting a kangaroo, that laminated glass might be the difference between a high-powered kick to the head or not. So, makes a difference. Yes. They do. Okay, so it's okay. It's all good. I'm a big believer I'm a big believer that if one person has a question, that there were probably 2 or 3 other people who had the same question. They just didn't have the guts to ask out loud. Okay, so tempered glass. Tempered glass is used in the side windows and in shower screens. So that way, when you accidentally fall through a shower screen, you don't cut yourself, right? And the side windows. Why are the side windows? Why are they made of tempered glass or toughened glass rather than this really good laminated glass? Yeah.
Because if you roll your car, you will smash it and get out.
Exactly. How are you going to smash it though? With your hands? Your hammer? Well, so you just carry a... So you can, yeah. Safety. Okay, so you can get these safety hammers, right? And they've got like a clip so that you can cut through your seatbelt if your seatbelt jams. Anyway, does anyone have one of these hammers in their car? No. Okay, so...
They always on the bus.
They are on the bus, that's right. Okay, so what are you going to do if your car falls into a river? What are you going to do so that you don't drown? You're not going to be able to wind down the window because... Okay, so what are we going to do? Instead, you're going to take the headrest. Exactly right. Look at it. Ready? 3. Bam! So, laminated glass, we said, is used on the windshields and it's used on storefronts so that people can't rob into your store, or can't break into your store. A word that I like that's going to be relevant in a second is that, what do you call it when you go looking past all the windows and you see if, oh, like there's a nice suit that I might buy, or there's a nice dress that I might buy, or there's like, oh, look at the new window shopping. In French, that word is called lèche vitrine, which is licking the windows. Window licking has a different meaning in English. There's also a song called Window Licker by Aphex Twin. It's got an interesting film clip. I'm not going to show it to you while I'm recording. Anyway, but it comes, vitrine means glass, right? Or shop front specifically, right? So the idea of shop fronts, you want them to be strong so that people can't smash into them and steal all your good stuff, right? So here we have, the next one is clay products. So the most commonly used engineering clay products, well, look around you, you might be able to see it. Bricks. Okay, bricks, also tiles, pipes, pottery, and also biomedical ceramics. So for example, the book talks a lot about alumina, which is used in dentures. Clay ceramics have been formed by hand on potter's wheels for thousands of years. These days, we produce clay bricks. They're usually extruded, or they can be pressed. I say that down below. We can slip cast porcelain. We'll talk about that below. What do? We fire it in a kiln, right? We fire it in the kiln. We get through a process called vitrification, right? It sounds a bit like vitrine, which we just learnt about. Let's go and have a look at some bricks. So, okay, here we've got a podcast. I learned about this on 99% Invisible. Is it better or worse than the Sand podcast? Worse, because the Sand podcast is the best podcast I've ever listened to. We're not up to that one yet. Types of bricks. Okay, so this brick here is extruded. That's what's got holes. These ones here are pressed. What do we call this indent? We call it a frog. And then you use the frog so it holds the mud, right? Or the mortar. It keys into the mortar. My understanding is that you put the frog on the bottom of the brick when you lay bricks, unless you're in Ireland, where I heard from a student recently that it's the reverse in Ireland, because, I don't know. From my understanding of, my dad lives in Ireland, he tells me that mostly use Besser blocks. You don't see a whole lot of clay brick construction, but who knows. Okay. We also use tiles in a variety of applications, and a place where we see tiles is on space shuttles. And this is why the Columbia had a disaster, is one of those tiles, they cracked, and suddenly the heat wasn't being insulated, right? Because we know that tiles are stable at high temperatures. On re-entry, there's very high temperatures. If those tiles aren't there to protect the space shuttle from high temperatures, the metal is exposed to high temperatures. Metal can deform at high temperatures or even melt. Right, so that's why those astronauts died. Okay. So, ceramics used at high temperatures are called refractories, and they're used in furnaces and in space shuttles. Abrasives are used in cutting, shaping, and grinding. And I've got a picture. I've got to find. Here we go. My picture here. So here you can see my picture for all my ceramic stuff goes on this picture. So let's have a look. What have I got? First of all, we said we've got cement products. We've got glasses. Yeah, she's a hipster wearing glasses. We have clay products. Here we have an extruded brick and a pressed brick. And then we have abrasives. This is an abrasive. Look, it's a saw that cuts through concrete and brick and tile, right? And concrete better blocks. But what is it made out of? It's made out of steel, but what's on the outside? Sorry? Diamond. Excellent. So diamond is used as an abrasive. Diamond, silicon carbide, tungsten carbide, also normal... Yes. Yeah. And also even just normal silica sand. I've said before how my keys will not scratch. My keys will not scratch my phone screen because my keys have a lower hardness than my screen. But a grain of sand in my pocket will scratch my screen. Yeah. So, okay, we've talked about abrasives. Down below, they're going to ask you to name 2 abrasives. Most people say diamond and sand. Okay, insulators. Concrete. So ceramics don't conduct electricity very well. So often we deliberately want to insulate things from electricity. Let me just see. Oh, okay. Before we move on from bricks, sorry, I have this open for a reason. Oh, I don't have any of my glasses notes yet. Luckily, I think I've already shown you that. Okay. So when I was at uni, in my last year of uni, I did my honours project. That's a picture of me building this mud brick house, right? So it's a ceramic product. It's biodegradable, right? It's relatively wear resistant, and a lot of the world still uses, if you listen to that brick podcast, they talk about how a lot of the world still uses adobe structures or mud brick structures. I based my my project based on someone else's PhD project, where he built mud brick houses and then he retrofitted them. So he then went to, I don't remember, I think he went to Guatemala. He went to somewhere in South America where he went and retrofitted a whole bunch of houses. And so he used readily available materials. He didn't use high cost materials. And then he tested them under earthquake conditions. My project was similar, just mine were new construction built out of solid monolithic adobe structures. Okay, now we're on to insulators. So insulators are used for transmission lines, and they're also used for overhead wiring, OHW. Right, we can see insulators used on the train lines. Right, and then we also use them for spark plugs, which is what you can see in the book. Okay. So that's insulators. Semiconductors are made from doped silicon. They are used to make transistors, the basis for modern computing. Yeah. What do we make computers out of? Transistors, pretty much. There's some other stuff, but mostly it's transistors. This is covered in much greater detail in later chapters. I have already recorded quite extensive videos where I talk about transistors, but for the moment, that's enough for chapter 1, year 11. Okay, we're now on to forming and shaping ceramics. Ceramics are often fired in kilns to improve their strength and hardness in a process called vitrification. Remember we talked about that? We talked about lèche vitrine. We talked about vitrification is when we fire bricks. Bricks can be either pressed or extruded. Slip casting is a process where liquid clay is used to make things like toilets and sinks. Plate glass is produced through a method called the Pilkington process, also known as the float process, where the molten glass is leveled out on molten tin to keep it flat and uniform. Spark plugs are made from a process, by pressing powder into rubber molds. So it's pressed into shape. Yeah. Alumina is usually the same thing, right? So we're making dentures. We usually take the ceramic powder and we press it and it fuses under heat. Okay, I have a video there of how glass is made. That will be available to you in links aside from these notes. I'll provide them for you as well. Okay, so I have a couple of questions. You might want to take these down because they're going to be for homework. What is concrete made from? Exactly right. Explain why Gorilla Glass is used in phone screens. Hard and tough. Okay, compare the use of tempered and laminated glass in vehicles. So why do we use both? Campbell, why do we use laminated glass in cars? It's the strong one. Where do we use it? Zach, it doesn't shatter. Where do we use it? The front, the windshield. Yeah. Okay, where do we use tempered or toughened glass? The side ones, so that we can escape. Identify two methods for producing bricks. Pressed and extruded. Identify two ceramic abrasives. Diamond and sand. Okay, define a refractory in an engineering context. Stable at high temperatures. But if you wrote withstand, I would still mark that as correct. Identify an application for a ceramic insulator. Spark plugs is the one I see a lot of. Some people do say transmission lines or overhead wiring lines. Okay, where are transistors used? They are the basis for computing. Yeah, so transistors are used in computers.